Alright, this is the independent practice for lesson 19, solving equations. We're going to be looking at problems 1 through 3 together so that you guys make sure that you know what you're doing when you go to do your practice work. Let's look at number 1 first. It says solve the following equation for A. It says A minus 32 equals 47. So first thing we need to do is look at what operation is being used. We know that this is subtraction. What's the opposite of subtraction? What's the inverse of subtraction? We know that the opposite of subtraction is addition. So we're going to rewrite this equation and we're going to be adding. So we have A minus 32 on this side, and it equals 47. And then we're going to add 32 to both sides. We're adding 32 to this side to get the variable a by itself, and we're adding 32 to this side to make the equation balanced. This should all sound very familiar at this point, since we've been looking at this for about a week and a half now. So if I owe someone $32 and I give them $32, I don't owe them any more money. So this is 0, and a is now by itself. So a equals, what's 7 plus 2 is 9, and 4 plus 3 is 7. So a equals 79. So our solution is D. Number 2, I'm going to be using different colors so that we don't get confused about what works for what. Ollie reads a story in a play. The play has 165 pages, which is 5 times as many pages as the story. Which equation could you use to find S, which is the number of pages in the story? So we know one side of our equation is going to equal 165. And so I'm looking at all these to see if I can get rid of any of them. This one I can get rid of because it has the variable on the wrong side. No others have the variable on the wrong side. So we already eliminated D because 165 is not attached to the story. It's actually attached for the play, right? The play has 165, not the story. So we know that the variable shouldn't go with the 165 because our variable is about story, not the play. All right, and then it says 5 times as many pages. So we know there should be a 5. Oh, did not circle the right thing there. We know that there should be a 5 attached to our variable. And what operation, if I say 5 times something, what does 5 times mean? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? 5 times means multiply. So we know that 5 is being multiplied by our variable. So we know it can't be addition, and we know it's not division. So our answer is C. Number 3, Caroline charges $15 per hour babysitting. Let H represent the number of hours, so they're giving us H, she babysits, and E represent how much she earns. Choose true or false for each statement. So we're going to work through all 5 of these together. H plus 15 equals E is the equation that represents how much Caroline earns after each hours. Well, no, because it says $15 per hour, so this is multiplying, not adding. Per hour means that you're multiplying, so this is false. If Caroline babysits for 5 hours, she earns $20. Well, let's see, what's 5 times 15? It's not going to be 20. It's going to be, let's see, 15 times 5. That's 5 times 5 is 25. 5 times 1 is 5, plus that is 75, so that's false as well. 15H equals E is the equation that represents how much Caroline earns after each hours. This is true. I already explained why. 15 per hour. This means you're multiplying. If it says per, this is a signal that it's multiplication. And we know that H is however many hours she does babysitting. And E is the total amount she earns. So it'd be 15 times H equals E, which is what it has here. If Caroline earns $52.50, then she babysat for 3.5 hours. We can see if this is true by using the equation. So our equation, I'm going to do it up here, but it's in orange so that it's different from this purple, just so you know. So we have 15 times 3.5. Remember that when I'm multiplying decimal values, I don't need to line up my decimals. They don't matter. You take them out and then you put them back in. So in my answer, I'm going to have one value behind my decimal. So 5 times 5 is 25. Excuse me. 5 times 1 is 5 plus 2 is 7. Put a 0 down here because we're moving into our ones. We were in our tenths column, now we're in our ones. 3 times 5 is 15. Put a 1 up there. 3 times 1 is 3, plus that is 4. Then add them. This is 5. This is 12. And we need one number behind our decimal, so our decimal goes here. And you can add a 0 here if you need to, but you really don't. It's just a placeholder 0. So, is this true? Let's see, 5250. 5250. Yes, it's true. 75F represents how much Caroline makes after F days, babysitting 5 hours a day. So if she babysits 5 hours a day, we've already looked at what that equals right here. So 75F represents how much Caroline makes after F days of babysitting 5 hours a day. So the 75 represents 5 hours. That's true. And if she did that every day, this equation would work. So this is also true. Alright, so I want you guys to notice a couple things about how I did this. Mostly, I want you to notice how I worked through each part of the question here. I didn't just randomly select answers like a lot of you guys tend to do. When you get questions that are like this, you need to make sure that you're working through each one. I also, up here, eliminated answers based on what I already knew. This is a lot smarter of a way to work. It doesn't take as much time or as much thinking as if I were to try and do the work for each one of these questions or each one of these solutions. This process of elimination works very well when you're doing work like this in math. So just a couple strategies that you can apply to other math situations. Alright, go ahead and try to do your practice book work and then check your work video for it.